Robots to Assist Math Learning,
created by Sophia McKee
and Kaylin McQuilkin.
Our robot's name is Rick Javier Solomon, and she is a GoPiGo robot. We use a Raspberry Pi 3B computer, and we program her with Python.
Sophia and I programmed Ricky to move forward for a certain amount of seconds. Eventually, we want to be able to program a certain distance.
This is the code Kaylin and I used to make Rick move forward for 2 seconds. Here we see Ricky in action.
Next, we did some math to figure out a way to make Ricky move forward a certain distance. Here's the information we started with. There are 18 encoder holes for 1 revolution. The diameter of the wheel is 63.66 millimeters. From this, we were able to determine the circumference of the wheel, which is 63.66 pi millimeters, which is approximately 200 millimeters.
With the math shown on this slide, we calculated that Ricky will move forward 1 meter for every 90 encoder holes.
This is the code we created to get Ricky to move forward 1 meter using our math from the previous slide. Here is Ricky moving forward exactly 1 meter.
One topic we learned about in pre-calculus is complex numbers. Complex numbers include the real numbers, but adds on a dimension for the imaginary part of the complex number. There are 2 forms for complex numbers, rectangular and polar. Rectangular form has a real component and an imaginary component. Polar form has an angle, also known as an argument, and a modulus, also known as a distance.
Because there are 2 different forms of complex numbers, there are 2 different ways to get to a point from the origin. For rectangular form, you first move on the real axis and then move on the imaginary axis. This means first move left or right and then move up or down. For polar form, first rotate by your argument and then move forward by your modulus.
We can use Ricky to show the conversion between polar and rectangular form. We will program Ricky to go to the polar coordinate 1 times the quantity of cosine 40 plus I sine of 40. Using the math that we learned in class, this should be the same as the rectangular coordinate 0.766 in the real direction and 0.643 in the imaginary direction. Note all our units were calculated in meters. Since the meter stick has the number of decimeters, we are really looking for the coordinate 76.6 and 64.3 I.
Here you can see Ricky helping us with our math.
Here are the pictures of where Ricky started and stopped. In the first picture, it is clear Ricky went forward exactly 1 meter. In the second picture, you can see Ricky correctly turned 40 degrees counterclockwise. This means Ricky is at the position 1 times the quantity of cosine 40 plus I sine of 40.
When we look at the real axis, our math predicted that the robot should be at 76.6 decimeters. When we took out our meter stick to measure, we found that the robot was exactly at this position.
Thanks for watching from all of us at Levining High. You silly robot, Ricky.